Welcome back, friends. We are going to continue our discussion which we had related to linear programming models. So in the last session we discussed about the how to formulate the problem in the linear programming model, and we formulated the problem by constructing the linear programming model. And the model which we constructed, we take an example that a company wanted to produce table and chair, and they have two products. So each unit of profit which they are going to earn from the table is 7 and from the chair is 5. So we written in our model maximizing the profit, that is 7t plus 5c. T and C is number of units which are of table and chair respectively which we are going to make, and we are constrained by the carpentry hours, painting hours, and we are also constrained by number of maximum chairs which we can produce, and we are also constrained by the minimum number of tables which we are required. And finally, I mentioned about we are going to have non-negativity constraint, that number of table and chair would be always more than or equal to 0. It cannot be negative. So let's understand this model and solve this model with the help of graphical model. We can solve this model with the help of both graphical as well as the simplex method, but in this session we are focusing on graphical model. Graphical model is a very simple model. It gives you a very deep insights to the problem and give you very important solution. But one of the limitation of graphical model is because you know the graphs are two dimensional, so you can always have only two dimension, that is on one side that is x-axis, other is a y-axis. So you will not have more than two products. If you have more than two products or more than two, in other words, if I say more than two decision variable, 3, 4, 5, 6 decision variable, then graphical model will not be applicable. So that is something constrained with the graphical model, but this is very powerful tool for beginners to understand linear programming. So let's plot our first thing in our first step in the graphical model is to plot all the constraint onto a graph. So we have a first constraint that is 3t plus 4c is equal to 2400. So we are going to calculate the values by calculating the intercepts of it. So intercepts are calculated by assuming firstly when assuming t is equal to 0. So what will be the value of c? That is 600 putting in this equation, and then when when c is 0, what will the value of t? That means it will come 800, and this figures we are going to plot onto a graph. That means we are going to plot t when t is 0, c is 600, we are plotting onto the graph, and when c is 0 and t is 800, we pointed onto the graph, and these two linear points we join together with a line, and which is a constraint line now. 3t plus 4c is equal to 2400. This is line of equality. Constraint is given as less than equal to 2400. So what will be the feasible reason for this particular thing? The feasible reason for this would be onto the how we should identify what is the feasible reason. The most easiest way is write your equation and take out the extreme values onto the both x-axis as well as onto the y-axis. So if you look into the extreme value, and if I put into my equation that extreme value on the both ends is, let's take 0, 0, we are not going to produce anything. So if we are going to produce nothing, 0 and 0, so that particular point my solution is going to be feasible. But if I put anything onto the both side, the farthest constraint, let's say if I going to produce more than 600 tables, let's say 800 tables, and at the same time number of chairs are also going to be 800. If I put into my equation will not be a feasible equation. So it means my area lies onto the other side. Always, friend, remember, area is onto the other side of the constraint. That means either it will be right or the left. So we have to check which side it is, whether it's right or left. So if it is coming less, so it is right. So in the same fashion, we are going to plot the painting constraint, painting time. The painting time constraint is 2t plus 1c is equal to 1000. So firstly we assume t is equal to 0. That means when we put this into this value, t is equal to 0. C will become 1000, and same way we put C is equal to 0, and then we'll get the value of T, that is 500, and we plot onto the diagram into the graph, and graphical will show again this line, and now again we have to check which side the area is. The area will be onto the again lower side, not on the upper side, because constraint given is less than equal to, as well as if which again test with the extreme values which I said. So you will find the area will be onto the side where equation is getting satisfied. Let's plot the last two another variables which we had, two other constraint which we had, not variable constraint we have. So C is equal to 450, so that will be directly plotted. C is equal to 450, and again the value of this particular constraint is given. It should be less than equal to, that is a maximum number of chair which you can produce. So area will be on lower side, not onto the upper side, and the other value which is given to us is that minimum number of tables should be 100. It should be more than equal to 100. So it means we are going to have a T is equal to 100 and area will be onto the other side. So now what we'll be doing, we will be doing finding out the common feasible region, which is a common feasible for all the points. The area which is common for all the points, that will be identified, and this particular graph is showing how which is a common area. So area which is given is the common. So the gray shaded area which we had is the feasible region. So there are two methods to look into the solution. One is go by the extreme value method, extreme points which are available. So we'll in the common feasible region, we'll look into all extreme points which are there, point A, B and C and D. We also can have the hit and trial method. So in the hit and trial method, let's firstly understand with the hit and trial method. In the hit and trial method, we'll be plotting different lines, linear lines onto this gray shaded area. Wherever this line is having a tangent with my gray shaded area, that will the particular point will be but these lines should be linear. Remember that part, these lines should be linear, and the line which is being touching the particular point will be the optimum solution point. Here you can see in this particular graph, the line touching is T is equal to 320 and C is equal to 360. That's the optimum point. You may find out the solution with the help of other method, that is on each particular point of interaction, that is we identify A, B and C and D. So all those points of interaction, you can calculate the value of T and C by unitary method into the linear programming and calculate the value, and wherever T value T and C gives you the maximum value into the profit function, that will be the best solution available. So all the extreme points when you saw where equations are interacting, you will be solving. With the solution you will find that the equation T is equal to 320 and C is equal to 360 will be the best solution, and if you put into the objective function, the objective function value will be 4040, which is the best possible solution. Friends, as I said, this graphical method is very helpful tool. We can have check other additional constraint if in case comes out, just like for example you need at least 75 more chair than table, then how you are going to take it? If I put this constraint that C is more than equal to T plus 75, or in other words C minus T is more than equal to 75, again I plot this particular constraint on the table, just my solution and onto my feasible region, because it's an additional constraint which has come. So with this additional constraint, my feasible solution area has been reduced, new optimum point is onto the same line, and my solution is T is 300 now. So my solution has been changed and my T is equal to now 300 and C is equal to 375. Because of this new additional constraint, my feasible area has been reduced. So T is 320 now and C is 360, which was my earlier solution. but that is no longer feasible. So new solution is T is 300, C is 375. So this is the way we can apply linear programming model. Thank you very much, friends.